Okay, I will start the discussion on the homework. Any of you have any problem with with our homework? If you have any problem, please let me know. Okay. For the first problem, second problem, third, or fifth. Oh yeah, by the way, the homework, you still need to. What's your name? Viva. Okay, for tomorrow you have to come at 7. Okay? You will be the first one that I will look for. Okay? Anyone having a problem with that? We will have another homework for next week. Okay? And the submission, in order to make it easier for me as well, because the previous submission was online. For the next two submission as well, for the current one, I believe you submit it online, right? Yeah. For the next one, for the last one, for next week, it will be online. Okay, just submit it. But we will do this discussion offline. Okay. Any question? Yakin ada pertanyaan? Yakin? Okay. I think it's better for us to take a look of this particular problem together. For this one, this number one, I believe it's quite simple, right? So it's a straight like that, horizontal, placed in the horizontal ground, and then it is known that the coefficient, static coefficient of friction is 0.5, and kinetic coefficient of friction is 0.4. Okay. 85 pound force is applied to the crane. Okay, and determine the magnitude and direction of the friction force exerted by the horizontal surface. So, in this case, what should we do? I'll do it. The black one. Okay, with the black t-shirt. Sorry, yeah, with the black shirt. What should we do on it? Draw the free body diagram. Yes, we can do that. Then you haven't done this before, right? I believe. Would you mind forward? At the end, now I can do it for you. Okay? Can I bring my? No. Just do it directly. Okay. So later your friend can. Let me see. That's the problem. This one is new one. Don't worry about that. If you do it by yourself, I believe you will be able to do it properly. Right? Just do it already. Okay, I direct the camera to you so your friend can see it. So we have 200 pound force downwards, normal force, friction force, G. And what should we do after we draw this free body diagram? Okay. Sigma F1 and X B equal to 0. And
stationary, which one the person stationary, the B has to be less than.
okay. Yeah.
That
Normal force multiplied by mass. Yeah. In that case, we need normal force, right? LD, yeah. Multiply by mu s is 0.5. In this case. Okay, so we say that we got it that the maximum friction force, static friction force, is 100 lbf, right? And we got it as well that the P is 85 lbf. Okay, what Audrey stated here is correct. In order to ensure that it's stationary, P is supposed to be less than Fs. Okay, in this case, is it less or more than? Less. So what is the conclusion here? What is the friction force? Okay, the friction force is 85 lbf. As simple as that. So okay, take care of it. So if we take a look at this, as I stated last week, there are three conditions, right? Based on our discussion last week, that may be there. The first one is we know that it's in a stationary condition. Okay. Let me show you guys. Okay, based on our discussion last week, okay, there are three types of friction problem conditions. The first one, the condition of impending motion is known to exist. Third one, actually, yeah, we have all of these three. Right? Impending motion is known to exist. Relative motion is known to exist. Okay, and then neither of the condition is known to exist. In this case, we don't know yet what is the condition. Okay, we only know that in this particular condition, we only know that the rate is 200 lbf. Okay, the force given is 85 lbf. Okay, and we know all the coefficient of friction, static and kinetic. Okay, and because of that, the first thing that we're supposed to do before we calculate for the friction force, okay, we have to ensure what type of friction which is happening here, what kind of condition which is happening here. Is it stationary? Is it in the stationary condition, or it's moving? Okay, or it's in the impending motion state. Ya, jadi kasus ini adalah kasus yang kita belum ketahui dari tiga kasus tadi. Impending motion diketahui terjadi, dia bergerak diketahui terjadi. Yang ketiga, kasus yang kedua tadi adalah kasusnya belum diketahui. Bisa di body motion, bisa dia diam, bisa dia bergerak. Ini adalah kasus yang kedua tadi. Kondisinya belum diketahui. Kalau kondisinya belum diketahui, yang harus kita lakukan pertama adalah mencari tahu apa yang terjadi pada dia. Kondisi mana yang terjadi pada dia? Dia diamkah? Dia bergerakkah? Ya, atau dia dalam kondisi impending motion. Nah, itu yang kita lakukan, itu yang tadi Audrey lakukan. Okay. That's what Audrey did. Ya, so basically all the problem in statics, we always start with this. We always start with the free body diagram. All statics problem we start with free body diagram. Then we take a look at that. Okay. Oh yeah, by the way, Audrey, you made a mistake. When we draw the free body diagram, we only draw the normal force there. We only draw the friction force. So we are not supposed to draw the ground anymore. The one that we try to take a look is just the frame, without the ground. So we're supposed to only draw the frame. And what is happening at the frame? We have the weight of the frame, we have the pushing force, 85 lbf, and we have a normal force from the ground. And because there is a friction, we have a friction force. Okay? Then we try to solve it. Using sigma Fy equal to 0, we got that normal force is equal to W, 200 lbf. And using sigma Fx equal to 0, we got that F is supposed to be equal to 85 lbf. Yeah, but we don't know yet whether it's moving or not. Or it is stationary, or it is in the impending motion condition. Okay, we have to check. How to check that? We have to take a look the maximum friction force possible, the maximum static friction force. If the F here less than the maximum friction force for the static friction, then it must be stationary. Okay. So we check for that, we calculate for the Fs, right? Yeah, we calculate for the Fs, and the value of the Fs here is 100 lbf, which means that the maximum friction force F total is 100 lbf, and the friction force that we use now is only 85, still under it. It means the curve is still stationary. Okay. Let me change the problem a little bit. If I replace this force, if I replace the force, if I replace the force here P with 105 lbf, what will happen in this case? What's your name? Yeah? Irshad. Okay, what will happen, Irshad? Not stationary, because if we calculate here, it's supposed to be using sigma Fx equal to 0 to be 105, right? The friction force there is supposed to be 105. And when we calculate the Fs, the maximum friction force possible, is 100 lbf. Is it possible for us to have friction force more than the maximum friction force it can be? Cannot. So the thing here is not possible. In that case, what will happen? It will move. Okay, the brake will move. If the brake moving, what friction coefficient are we supposed to use? Kinetic friction coefficient. In this case, instead of using mu s, you're supposed to use mu k. So we will have a friction force, kinetic friction force equal to normal force. In this case, is 200 multiplied by mu k. Our mu k is 0.4. So the friction force is supposed to be 80 lbf. Maybe some of you will ask, why the friction force is 80 lbf and the pushing force is 105 lbf? It means that the equilibrium condition is not fulfilled. Yes, it's right. In this condition, the equilibrium condition is not fulfilled. So you can see, right? There is a delta 105 lbf and 80 lbf, so there is a delta of 25 lbf. Right? Those 25 lbf will be used to accelerate the brake. Mungkin di antara kalian yang bertanya, Pak, ini gaya dorongnya 105, gaya biasanya 80. Ada perbedaan di sana, perbedaannya adalah 25 ya, horizontal. Nah, 25 lbf itu sebenarnya digunakan untuk mengakselerasi si otaknya. Seperti itu. Mungkin kalau dosennya kurang kerjaan, ditambah makanya ini. Ya. Akselerasinya berapa? Ya, akselerasinya bisa tinggal dihitung kan? Karena kita tahu gini, tinggal F sama dengan M kali A. Walaupun ini agak complicated karena agak ribet karena kita pakai satuan lbf bukan satuan Newton. Ya. Tapi nggak ada masalah di sini. Seperti itu. Nah, oke. The last case, okay, for the last case, I think I will say again. I replace the figure with 100 lbf. In this case, what will happen? You with the blue shirt, impending motion. We can see here if it's a 100 lbf, then the F later will be 100 lbf using sigma Fx equals 0. And if we compare it with Fs, the maximum static friction force is 100 lbf. So all the friction force, all the static friction force is used. In that case, we call it as impending motion. Yes, it's true. Okay. So just now I explained those three conditions. Okay, stationary, then moving, then impending motion. Those are the conditions that can happen in the friction case. Okay. Any question about this? Any question? No? Mark with the black shirt. Do you understand? What's your name? Fatima. Fatima, do you understand? Okay, good. If you have any problem, please ask me directly. Okay? I'll try my best to make sure that the whole class understand about the things that I teach here. Okay, for this problem, anyone having a problem here? Yeah. So sorry for those who are at home, okay? Because I just realized that just now from the beginning I mirrored the video. Why didn't you guys tell me about it? For those who are at home. Hello? Nabil? Adam? Nabil? Don't say that you are sleeping.
Not sure, sir. Not sure how to tell.
Now it's clear, right?
Yes.
Okay, good. Okay, for this problem, I believe it's similar to the previous one, right? So the question here, there is three cases, right? The first case is if the the P there is equal to 200 Newton, what will happen with the friction force? Then the second case, the P required to initiate the motion, like that, and then friction force when the P is equal to 600 Newton. So those three cases. Okay, the first case, most likely it will be stationary, right? The result is supposed to be stationary. Okay, actually it's quite the same as the previous one, but the free body diagram is just slightly more complicated because there is an angle there, there is an angle here, there is an angle here as well. So in order to calculate for the normal force, yes, you have to consider for it. Okay, but I believe it's not that hard. You will check the sure, yes. Can you do this? Yes. I mean, have you have any problem with this problem? Yes, you have problem. See, if the friction force, sorry, if the P is equal to 600, what is the problem with that? What is the problem with it? I think let's. Okay. I think let's explore it. Okay, the first thing first, we draw the free body diagram. Weight is slanted 15 degrees. Then the force is slanted as well, 20 degrees. Okay. What forces that we have here?
The sign is
Yeah, no, I mean, besides this force, P, what other forces that we have? Normal force, before normal force, I believe is supposed to take a look at the weight, right? What is the weight? Assume we use 10 meter per second square. So we have 1000, right? Besides the weight, what else? Normal force. Normal force is always perpendicular to the contact area. So it's like this. Normal force. What else? Friction. Okay. So what's the problem with it? Yeah. You are having a problem with C when the P is equal to 600 Newton, right? Right. Okay. The question is, how much is F here? Right? So in order to solve this, what we're supposed to do? just calculate, right? I think I will just use this. This one is my x. This one is my y. Okay. So x and y, I use it the same direction as the ground. Parallel to the ground is x. The perpendicular to the ground is y. Okay. Then what we supposed to do next? As usual, equilibrium equation, right? Okay. The first equilibrium equation that we're supposed to do here is what? Sigma fy. Okay, sigma fy equal to 0. What we have at sigma at the y direction here? Sorry, p sine 20. Okay, so in this case 600 newtons sine 20 degrees. What else? The weight. Sine or cosinus 50? Cosinus. So minus weight 1000 multiplied by cosinus 15 degrees. What else? Plus n, right? Equal to 0. From this we get normal force, right? And for those who already calculate, what is our value of normal force? Just using your homework. What is our value for normal force? Sorry? Anyone? What is the normal force value?
60.7.
60.71. Is it correct?
Are you using the 600 or 200?
Huh? 600.
Or the C or the A in the A?
See. We try to solve C because your friend having a problem with C. So normal force is this. Then, in order to get the friction force, we use what? Okay, sigma x equal to 0. Okay, for sigma x, what we have? Yeah, force Q.
P cosinus.
3 cosinus 20. Okay, so 600 Newton. Cosinus 20 degrees. What else?
Weight times sin 50.
Yep, that's minus, right? Minus 1000 times sin 50 degrees. Okay, and
Minus the friction.
minus the friction. Equal to 0. In this case, what is our friction force value? In this calculation. No, just based on this calculation. Would you want to calculate it for me? 305. But as usual, we know right, this one is 305 Newton. But we don't know yet whether it is moving or not. Okay, so we have to check, right? We have to check with this one. Okay, we have to check with the normal force and the static friction coefficient. So Fs is supposed to be normal force. Okay, Fs is supposed to be normal force multiplied by the maximum friction force, the maximum static friction force is supposed to be normal force multiplied by what? Multiplied by mu, which mu? Static, right? Okay, so in this case, our normal force is 760.71. Then our mu s is 0.3, right? Okay, our mu s is 0.3. So our Fs is what? 228 Newton. That's our FS, the maximum static friction force. So what do you think? This one is the maximum static friction force, and this one is the required friction force to make it stationary. Which one is bigger? Tell me, which one is bigger? Which one is bigger, 305 or 225? 225, 325 or 228? 305. 305 is the required friction force. 228 is the maximum friction force, the maximum static friction force that can be provided by the system. The one that is required is more, right? So what is happening? Moving. Okay, so the conclusion here, it will be moving. Okay, if it's moving, then the friction force here is completely wrong, right? Now we have to calculate the actual friction force that is available. What we're supposed to do? Okay. Yeah, normal force multiplied by the mu k, right? 760.71 multiplied by 0.2. So in this case, it's I have 52 something. So this is that. Clear. So the first thing that you're supposed to do, try to know what is happening to the things. Okay? Is it stationary? Is it impending motion or it's moving? If it's moving, then we have to use mu k. If it's stationary, we have to take a look whether the friction force is more than the available, it is impending motion or less than that. Okay? If it's less than that, then we use the calculated friction force. For impending motion, then we can just use Fs then. Okay. Yeah. That's the problem, because it's been too long for us to having an online class. We are running out of marker. That's the case. Yeah. This one is better. I think it's okay. Where did you get it from? Oh, nice. So we have the blue one. Blue is supposed to be okay. What did it? Blue is it okay or not? Not okay. Okay, then in that case, I'll borrow yours. Okay, thank you very much. What? Oh. Yeah, one. If it's not, then later I have to clean it up. Okay? Thank you very much. Any question here? Now some of you do it digitally, or just using cell phone. Okay? Sorry, to find normal force. The P for the question. So we have three questions. The first question is P equal to 200 meters. So for A, P equal to 100, and we have to use that. For B, that's the one that we find out C. For C is B is equal to 100 meters. That's now we try to solve for C. So that's why we use C. Yes, of course. A, B, C, the normal force all are different. Yeah, because now the normal force is not only depending on the weight. Previously, it's depending on the weight, right? Only. For this one, it's depending on the weight and the speed, because speed is slanted. Okay? Okay, then we will go for the next one. Yeah. For this particular problem is, do you have any problem here? Right? You don't know about it? Counting part. Okay, yes, in that case, we will discuss it. So you raise your hand and start. I don't understand your question. You are confused, eh? Prove it. But the problem is this one. We cannot do that. It's slightly different than the one that I explained in the class. Because you can see for this particular refrigerator, if you take a look at your refrigerator, the contact point is slightly different than the wardrobe board, right? Because there is a point where the contact happens. And based on the picture here, the contact is only happening at A and B only. You get it? So the contact between the refrigerator and the ground only happening at A and B. So there is no contact in between those. That's why this tilting problem is slightly different than the one that I discussed previously in the past. Okay? Let's discuss about it, okay? Okay, as usual, I think, would you mind to draw the three-body diagram for me? Seems like you have a problem with that. So you try to draw it. Don't worry, I will guide it. Slightly better. Nice, okay. Okay, what else? Here we have. Yes. I think you can just name it and A and B. Yeah, thank you. Okay. Yeah, don't worry, you can just return back. So basically, if we take a look at the three-body diagram, it will be like this. Okay, there will be weight there will be pushing force F there, and the weight is 220 lbf. FA, FB, Okay, there is a normal force at A, normal force at B, friction force at A, friction force at B. The height there is 16 inches. Sorry, 60, not 60, 60. Okay, and the width here is 30 inches. What we supposed to do here, the one in question is when the force F is applied to push the refrigerator, okay, will it slip first or will it tip over first? That's the question. Whether it will slip first or tip over first. What do you think? You open it with a nice hair. What's the white hair? Is it white or pink or what? Yeah, you open it. Is it white or pink? Your hair? Huh? White, pink. What we supposed to do here? What we supposed to do? Use the equilibrium. Okay. Are you sure it's the same? No, it won't. That's the problem. Okay? Some of you maybe make assumption that NA and NB are the same. Just weight divided by 2, but it's not. It won't be. That's the challenge, right? Prashant, can you do it?
I did the same mistake.
Oh, the same. Okay, because why it won't be the same? Because F is here, right? If you calculate towards any point here, F will create a moment, right? Okay, and the moment there will be nullified by the normal force. So the amount of the normal force between the left and the right will be different. That's the challenge, right? Okay, but the problem is, are you required to find out the value of the friction force? Are you required to find out the value of F, pushing force, which make it moving? No, right? The one in question is whether it will tip over first or slide first, right? So if we can check, if we can ensure that it won't tip over or it will tip over, it will be enough, right? You get it? That's the thing that we're supposed to do. Okay? If it's tipping over, if it's tip over, what actually will happen if it starts to tip over? About to tip over. So, like impending motion is the critical condition, right? Below impending motion, the condition is stationary. Above the impending motion, the condition is moving. So that's the critical condition. Now, we are trying to take a look at the critical condition for tipping. Okay, here, in this case, right? The critical condition for tipping in this case is what? In the previous case where normal force can be anywhere here, okay, the critical condition if the normal force is exactly at the edge, right? Last week I explained to you guys. But in this case, it's slightly different because normal force is happening at A and at B. Try to imagine. Okay. You with the white hair, what's your name? Huh? Arab. Arab. Mary or Beryl. Beryl. Try to imagine. If it's start to tip over, what will happen to the normal force? Is there any possibility that some of the normal force will be gone before it starts to before it hits something? Maybe. Try to imagine. If you have things like that, if it starts to tip over, what will happen to the normal force at A? It will be zero. That's the critical condition. Okay? It's based on your imagination. Based on your logic. When it starts to tip over, there will be no normal force at A. No normal force. It starts to tip over. So that's the critical condition. That's the thing that we have to check. The condition where A, okay, the condition where A is zero. Normal force at A is zero. So we try to check that. In that condition, will it slip first or tip over first? Okay, if based on our check in that condition, it will slip over, then before that it will slip over. Okay, not slip, sorry, slip over. What has slip over? Tip over. Okay. If it's at that critical condition, we can determine whether it slips, right? It slips at the condition means previously, it will slip as well. Okay? But if it's that condition, the movement is not yet there. It means that we have to imply that we have to give higher force, right? In that case, it will tip over first. You get it? So what we want to do is to check the critical condition. Okay, we want to check the critical condition. The critical condition is when tipping over is supposed to happen. That's the case where normal force at A is zero. We check at the condition, okay, whether it's already start moving on. Okay, if it start moving at that time, if it's already moving at that time, at that particular point, particular condition, then our assumption, our conclusion is it will slip. Okay, it slips. But if it's that critical condition, okay, the friction force that is bigger than the pushing force, okay, most likely it will tip over. You get it, guys? Okay, you just need to answer the things that need to be answered. You don't have to think. You don't have to think about anything else. Okay, so let's check. If it's not the condition, then I will put it as critical condition. Okay, for the critical condition, I will just delete all the normal force, all the friction force at A. I will delete it. I will just concentrate on friction force and normal force at B. Okay, in this condition, now it's much simpler. If we want to do the equilibrium here, okay, what equation that we supposed to use? Moment at B, okay, moment at B. Sigma moment at B equal to 0. Okay, sigma moment at B equal to 0. So You are trying to find the maximum force just before it tips over, right? That's what Sam did. Okay? If the force is bigger, so sigma moment at P here, what we will have is F multiplied by 60 inches, okay, minus W 220 multiplied by 50, right? 50 inches is equal to 0. If F is bigger than that, it will tip over. So, because it's critical condition that we try to take a look, we try to give the force which about to make it tip over. Okay? So in this case, what is the force value? 55, that's right, 55 LBM. That's the maximum force that we can give before it starts to tip over. Now, the next one. We have to solve for FB and NB, right? In order to solve for NB, what are we supposed to do? Right, sigma Fy equal to 0. Well, we have that. Just based on this P-value diagram. The weight, so 220 LBF, what else? No, minus norm, of course, equal to 0. So NB will be supposed to be same as 220 as well, right? Okay, 120 LBF. Okay, now you with the curly hair over there. What's your name? Radit. Okay, Radit. I want to find out the FP here. What I supposed to do? Which equation I supposed to use? Sigma Fy, why already use it? FP is horizontal force, yeah? So sigma F what? Fx, okay? We use sigma Fx equal to 0. Well, we have that. What forces there is in the x direction? F there we have 55, right? So 55 LBF. What else? Friction, okay, minus Fp equal to 0. So LFP will be the same as 55 LBF. Now, we know the value of NB, we have the value of Fb. As usual, we can check, right? Whether this is below the maximum friction force, maximum static friction force or not. To check whether it slips or not, right? You with the white polo shirt. Yep. What is the maximum friction force, maximum static friction force in this case? Fs, right? And V times mu S or mu K. We don't have mu K, so only mu S, okay? And B is equal to 220 multiplied by 0.1. What we have? 44. L B F. Based on this comparison, tell you what is our conclusion? Fs is 44 LBF, Fp is 55 LBF. Okay, the maximum friction force is lower than the required friction force, right? This one is the required friction force, right? So the case here, it will swing. So the answer here, it will slip first before it tips over. Because that's the question. You are not required to find out the friction force there, right? No. We just need to determine whether it slips first or whether it tips over. So that's the answer. Okay? You guys understand about it? Any questions? Neila? Question? Neila, you understand? Tip over, okay. So basically this, what we supposed to check here is the critical condition, okay, Nela? So the one which determines whether it will tip over is actually this. Okay? If the normal force and friction force is at the critical condition and it's only happening at B, okay? If the moment here, the moment due to pushing force here is bigger than the moment due to weight, what will happen? It will tip straight. Right, Nela? Can you imagine it, Nela? The moment due to the F bigger than the moment due to the W, okay, it will tip over. You get it? Because if it's the same like this, it's not yet tipping over. This is the critical condition, but if the F here is bigger than the critical condition, which just now is calculated equal to 55,000, it will tip over, right? You get it? You with the black. Okay. Maybe I will explain in bahasa to make sure that the regular students understand what it is as well. Jika gaya yang diberikan, oke, gaya F itu akan memberikan momen kan di titik D. Ini kondisi kritikal. Oke, kondisi kritikal artinya normal force di titik A itu sudah hilang. Ya. Nah, kalau itu kondisi kritikal dan gaya F tadi memberikan momen yang lebih besar daripada gaya W terhadap titik, artinya apa? Ada momen kan? Sigma momennya tidak sama dengan 0. Kalau sigma momen tidak sama dengan 0, artinya apa? Muter. Itu kondisi tip over. Tadi kan itu kondisi kritikal ya, kondisi apa yang lebih dari kritikal ya. Nah, tadi kenapa kok yang kita cek itu adalah kondisi kritikal, bukan kondisi yang lebih dari kritikal? Itu cuma untuk mengecek saat kondisi kritikal ini dia udah gerak belum. Kalau dia belum gerak saat kondisi kritikal ini, ya kalau dia belum gerak, artinya supaya dia bisa bergerak kan harus ditambah gaya. Berarti lebih dari kondisi kritikal kan? Pasti muter loh, gitu loh. Oke. Nah, dalam kondisi ini setelah dicek, ya besar gaya F itu supaya keseimbangannya terjaga, itu ada di 55 LPF. Oke, dengan gaya 55 LPF itu kita hitung semua, normal force-nya 220, friction force yang harus disediakan supaya dia tetap stationary itu 55. Nah tadi yang ngecek tadi masih begitu tadi namanya itu Rehan. Tadi kamu ngecek ini tadi FS-nya maksimum friction force-nya itu cuma 44 lbf. Kalau maksimum friction force-nya cuma 44, padahal yang dibutuhkan 55, artinya apa? Artinya apa, Mas? Dia gerak atau tidak? Dia slip atau tidak? Slip kan? Ini gaya maksimumnya yang tersedia itu 44. Tetapi yang dibutuhkan 55. Yang dibutuhkan lebih besar kan? Nggak bisa nahan dia, slip kan? Nah, kondisi kritikal dia sleep. Rollovernya belum, pick overnya belum terjadi, ya berarti setuju dong. Ini kesimpulannya. Sleep. Gitu, bayang. Jadi banyak kasus di mana nanti kalian akan harus melihat kondisi kritikal. Batas tip overnya, saat batas tip over itu dia gerak atau tidak? Kalau dia gerak still moving, ya, berarti dia sleep. Tetapi kalau di batas tip over dia tidak gerak, berarti butuh tambahan gaya. Cenderungnya dia akan tip over. Oke? Ini adalah kondisi perbatasan yang mirip dengan perbatasan masalah gerak, diam, atau impending motion. Ya, ini juga terjadi pada tip over. Dan yang itu yang biasanya kita akan sering hadapi, kondisi perbatasan antara dia gerak atau dia tipping. Oke. Sampai di sini ada pertanyaan? Silahkan. Mbak yang rambut putih sudah paham? By the way, I want to ask you something. Although most of you are professionals, do you understand it better when I explain in English or understand it better when I explain in Bahasa? Just try to be honest. You are international. But like it or not, because you are international students, I have to deliver in English. So, if you have any problem, then, especially for those regular students, if you have any problem, I will re-explain it in class. Okay? Jadi apa? Berapa? Batasnya yang dicek itu di batas. So for today, I will concentrate on the explanation of the tipping over. Okay, but before I explain again about the tip over, I think I will discuss a little bit on this. Okay, then I will discuss a bit about the tip over case. That last week I already explained about. Okay, what is particular problem? Anyone having a problem here? Okay, if you have any problem here, please let me know. Chan, do you have any problem? No. So it's not that hard. No. Oh, yeah, your second midterm exam, is it easy or hard? Is it hard? Which one? Number 1 or number 2? Number 1? Only number 1. Number 1 is easy. Then number 1 is the frame, right? The machine problem, right? I will be the one who will grade the number 1. I'm not sure. Maybe I will check. What's your grade for number 1? If you do it properly for number 1, okay, I tell you, you just need 3 equations. As simple as 5 minutes done. Serius? 3 pasangan. Mau ya? Kalau saya suruh kerjain nggak ada. Nah, salah gimana? Nah, gini. Okay, so basically, for number 1, right? You can take the longer route. Yes, you do all the equation necessary, but it's not necessary to do that. Okay, just in order to answer the question properly, 3 equations is enough. Okay, 1 sigma moment for the top one, then equilibrium at 1 point as well. Using sigma fx and sigma fy, it's that. Never mind. So it's fun. But why I discuss about it? Because most likely machine will still be there. Machine and frame will still be there in the final exam. Okay, for your final exam, it will cover friction. That's for sure. Friction may be by friction and wedges. Okay. Starting from tomorrow, I will discuss about wedges. It's not the wedge that the girl here is normally used, right? Not about shoes, we are not talking about shoes, but wedge that we are supposed to use to hold the door from moving. Okay, wedge itu di situ bukan wedges satu ya. Saya nggak tahu di sini ada yang pakai wedges itu. Ya? Bukan. Wedges itu kamu kurang banyak gaul sama cewek. Heels itu satu titik, gitu ya. Kalau wedges itu agak panjang gitu, tapi tinggi itu tetap. Pernah lihat kan? Oke, kamu pernah punya pacar?
Alhamdulillah.
Alhamdulillah. Okay, so we are not talking about wedges that girls normally use, but we will talk about wedges which we supposed to use to hold the door from moving. You know it? Kalau bahasa Indonesia kenal nama paksa. Itu buat nyumpal pintu supaya tidak bergerak ya. Kalau kalian tahu IKEA itu jual wedge yang untuk nyumpal pintu itu kan, ya kayak gitu. Itu wedge. Nah, besok kita akan bicarakan itu, cuman hari ini kita fokusnya di drive friction dan di masalah tilting ya, masalah tip over. Oke? For this problem, the guy over there who has a pandemic hat, yep, of you over there. What are we supposed to do here? Free body diagram, okay? Which free body diagram that we're supposed to try to solve? The man. Okay, we can draw the free body diagram for the man. Yes. This one. If we draw the free body diagram of the man, please mind my drawing. Okay? I'm not very good with drawing. To be honest with you, when I was at your age, right, I got one subject in my lifetime when I finished my study in IB. I only have one subject that I see. And you know what? What is that? Gambar teknik. No. My drawing is very bad. But the rest, I got A or B. We don't have A here. Okay? Just like this. Okay? What forces that we have here? That's right. Static. Okay. Oh, you mean this one? From the rope, you mean? Okay. What else? How about weight? The weight is at G, right? The weight is, what is the value of the weight? And 80, right? Now, what else? FC, what we have there at C? Friction only? In order to have a friction, you have to have what? Normal force. So it must be the normal force. We will have a normal force here. And we have the friction. Just like this, right? It's supposed to be enough. Right? So we have three unknowns, and we have how many equations that we have? We have three. Sigma moment, sigma fy equal to 0, sigma fx equal to 0. Which one that you want to solve first? Sorry, FA there, forfeit. Wait a minute, there is a P here. So there's a tension. Wait a minute. Forfeit. Center of gravity. Okay. Okay. Which one do you want to solve first? Sigma moment at FA. Yes, it. Moment at A or what? Moment at A. Using moment at A, we can solve it. Sorry. Sigma moment at A equal to 0. What we will get there? Sigma moment at A. We get a normal force. Actually, here there will be a friction as well. Actually, it's not just Fa, but here there will be friction force A, and sorry, normal force is supposed to be going over there, right? Normal force at A, then at C, something like this. Okay. Using sigma moment at A, you will be able to get the NC. Okay, what is the value of NC there? So this one will be 180 multiplied by, what is that? 180 multiplied by 3.25, right? Okay, minus NC multiplied by perfect equal to 0. What is the value of NC here? Right, son?
I think you forgot the friction.
The friction?
FC.
Wait, FC. Oh yeah, it's slightly.
It has 0.17.
Ah, yeah. FC. Okay, FC. So FC multiplied by 0.75. That's it. Yeah, that's right. Well, you cannot solve anything there. Then, in this case, FC is we can replace it with NC multiplied by US. Okay. Then after this, what equation do we have? Next. Okay, sigma F1. Well, we have that. Okay. FA plus FC minus 180 equal to 0. Right? Okay. We can name it like NA multiplied by S plus NC multiplied by S minus 580 equal to 0. Okay, what else? sigma fx, right? Equal to 0. What we have at sigma fx? Only an a and an c. And a minus n c equal to 0. And a equal to n c, right? I will name it as an a equal to n c equal to normal force. And okay, so later here, I will replace this with n. I will replace this with n as well. Okay. So we have two other equations to solve for that. This equation, C is n so. Okay. This equation and this equation. Can we solve for it? We have two equations there, right? And we have two unknowns there, n and us. N and us, right? So we can solve. Okay. Based on the calculation, what is the value of n and what is the value of us? Actually, what we need is just us, right? Yeah. So what is the value of us? It's that. Based on your calculation here. You? Oh, lupa. Sian, kamu ngapain benar nggak?
0.76.
0.76. Oh, here. Yep. 0.76. This is it. Okay, so you have at the end you have two equations which has n and us. This one and this one. Then you can solve for n and us. Okay. Any question about this? Before I try to finish up with the tilting. Yes, sir. With the tipping condition. Friction. Tipping condition. Okay. This is the things that we discussed before. Okay, this is the things that we discussed before. Okay, for tipping, normally for tipping, right? The case which normally happening is like this instead of the things that we discussed before. Okay, for the things here, the tipping is only the friction is only happening at both ends. Okay, but for most of the tipping case, the friction and the normal force is happening on the contact between the ground and the surface. Okay, unfortunately here, the contact is only happening at 2 points. But in this case, the contact is happening at the whole surface area. Okay, and as usual when we talk about tipping, okay, the condition is the same as what we discussed before. Yeah, there are 3 conditions. The first one is tipping is not happening. Okay. And the box is in stationary condition as well. Okay, that's the first one. The second one, okay, sorry, actually it's more than that. The second one is tipping is not happening, but it's in impending motion. The third one, tipping is not happening, but it's in moving condition. Okay, the fourth one, okay, it's at the stationary condition, but tipping is happening. The friction is there, it's enough to hold it, but tipping is happening. So there are four cases which is possible. Okay, so basically, if you try to take a look at those cases, you can try to imagine it. Okay, if you have a chair like this, right? Okay, if you push it, okay, the first thing that may be there is you pushing it, but it's not moving and it's not tipping. That's the first case. Okay, the second case, I push it and it's in condition of impending motion, about to move. Okay, the third one, I push it more than impending motion, it's moving. Okay, that's the third condition. The fourth one, I push it. Okay, the friction there is sufficient to hold it, but tipping is happening. That's the fourth one. Okay. I'm not sure whether okay. I made a mistake again. The student at home cannot see the chat. Okay. So four cases. There are four cases. Yeah. The first one, I push. Friction is there. Is enough to hold the things in the stationary position. Okay. The second one, I push. It's in the impending motion condition, almost moving. Okay. The third one, I push. The friction is not enough, so it's moving. That's the third condition. The fourth one, I push. The friction enough, but it's tipping. Okay. Try to concentrate. Just don't think about your girlfriend. Okay. It seems like your mind is going anywhere else. Are you sure? You're not thinking anything. Are you listening? You're not thinking anything weird, right? Are you listening?
Yes.
Okay, good. You're not supposed to think anything weird.
No, sir.
See, right? Your face is getting wet. Sorry about that. Just kidding. So those are the four conditions which may happen in the tipping case. Okay? Anyone want to ask question first about those? And for the tipping condition, right? The way to check it is just the critical conditions. Okay, to check whether tipping happening or not, we just need to check the critical condition. When we talk about critical condition, the friction and the normal force happening at which point? Which point? Fatima? Which point, Fatima? If tipping is about to happen, the friction and the normal force happening at which location? This one, right? In H. Right? You mean this one? Right? It's right. It's happening at the H. That's the critical condition that we're supposed to check. To check whether tipping is happening or not. Okay? We see at a particular condition, we see at a particular critical condition, whether the friction is enough or not to hold it in place. If the friction is enough to hold it in place at the critical condition, then most likely we have to increase the force. Most likely tip over with tipping over. That's the way it is. Okay? So remember about those four cases. Yeah? Okay, now let's talk about tipping condition. Okay, now let's talk about tipping condition. So, when we talk about tipping condition, this is the frame. Okay, there will be weight there, then there will be force there, P, weight. Okay, the friction force can be anywhere at this bottom area. Can be anywhere because normal force is supposed to be representation of the normal contact pressure here. Because if we have something like this, most likely the contact pressure will be linear like this. So later, we can find the concentrated normal force, which is representing the distributed normal force. Okay, but in this case, we are not talking about distributed normal force at all. So what we will talk about is where is the concentrated normal force representation and the location of it. That's all. Okay, but this is the explanation on why the normal force can be anywhere at the bottom of the surface. Okay, not necessarily have to be at the middle, in the middle. It's because actually the things that is happening there is distributed normal force, but we represent it with one concentrated normal force. Okay, so we are not talking about the distribution. We just talk about the value of the normal force and where it happening. Okay. Next, normal force, then friction force. Okay, I think I will just make a case. Okay, if W is 100 kilogram, so 1000 Newton. Yeah. Mu S is equal to 0.5. Mu K is equal to 0.2. Okay. Then the height here, 1.5 meters maybe. Okay. The height there is 1.5 meters, and the pushing force that I gave. Okay. The pushing force that I gave is, for example, 400 Newton. Okay. Among those four cases, okay, stationary, impending motion, and then moving, tipping. Which one of this is happening? Sorry for my writing. Okay? My writing is very good. Right? I believe you can read it properly. Right? Are you sure? No, right? I know. Okay. My friend at mechanical engineering 03 told me that my writing is like that. I'm not sure what is the English term for it. Tadi rumput. Yeah. But me myself can read it, so it's supposed to be okay. If you have any problem with reading it, please let me know. Okay. So we have four cases: stationary, impending motion, moving, and number 4 is tipping. Okay. Among these four conditions, okay, which one is happening? Oh. Okay. Among these four conditions, which one is happening in this case? What we supposed to do? We have to check. Okay, I forgot something. the weight here, sorry, the width here is 0.5 weight. That's the whole weight. Can anyone help me? What we're supposed to do here? Aurelia. Yeah. Aurelia, what are we supposed to do? That's it. Check the condition. Okay. What are we supposed to do first? It's not like that, but okay, but it's a good starting point. I will tell you on how to handle it. Okay, the first thing first, you have to check about the value of f and the value of n, which is necessary there. We are not talking about whether it will tilt, whether it will tip over, or whether it will slip like that. Don't talk about that yet. Okay, just get the value of f and n, which is necessary. Okay, to handle it in the stationary condition. How to do so? Sigma f equal to 0, sigma fy equals 0. Right? As simple as that. Using sigma fy equal to 0, what we will get here is normal force equal to weight, right? So normal force is equal to 1000 Newton. Using sigma fx equal to 0, what we will get here? Friction force will be equal to 400 Newton, right? Okay. Now, using sigma moment, we will be able to get the x. Correct, right? Using sigma moment, we will be able to get the x. Okay. For example, I will just try to do sigma moment at this condition, at this point, sorry. What we will get? How do you what we will get? Sorry? Sigma moment at this point. The distance here, x times w. Okay, 1000 multiplied by x, then minus what? Minus this, right? 400 multiplied by 1.5. So we will be able to get the x value. X value is what? In this case, 600 divided by 1000, 0.6, right? Correct? 0.6 meter. If you take a look at this, right? This is the center of it. This one, the width is 0.5 meters. Okay? If you see this condition, x is equal to 0.6 meter. Where the location of it? Where the location of the friction and normal force? It's over here, right? What is happening there? It will tip over. Okay, it will tip over, but one thing, we are not so sure yet, okay, because we haven't checked about this one. Okay, we haven't checked about the maximum friction force available there. Okay, if we check the maximum friction force, what is the maximum friction force there? Hmm? 500 Newton. So the maximum friction force is more than the required friction force, right? So what does it mean? It will be staying stationary, right? So there is no possible of movement. So in that case, in order to make it, in order to fulfill this condition, right? The x here, like it or not, must be equal to 0.6 meter, right? Because all the assumption here is on stationary condition. So x must be 0.6 meter, which is not possible here because the location of the friction force will be here, normal force will be there, which is outside of the box line. So in this case, what is the conclusion? In this case, what is the conclusion? Tip over. In this case, the conclusion is tip over because tipping over will happen if the friction force and normal forces go beyond the contact area. This is the contact area and this is the normal force and friction force. It's not possible, right? So it will tip over. That's the case of tipping over. Okay? Any question here? That's the first case, tip over. Okay? Not the first phrase, yeah? Tip over. Yeah, something like that. Actually, I can give you some other example on the moving example, impending motion and stationary. For example, if the height here now is becoming, instead of 1.5 meter, I put it at 0.5 meter. Yes, but I put it at 0.5 meter. Okay. The force there is still 400 Newton. Okay. The force there is still 400 Newton. Okay. In this case, if we use sigma fx equal to 0, the results will still be 400 Newton. The F will be still 400 Newton. Normal force will still be 1000. But if we use the sigma moment here instead of this, right? What we have here is 1000x minus 400 multiplied by 0.5. So in this case, what we will get is 0.2 meters, right? When I lower the force, 0.2 meter, that's the x is 0.2 meter. Remember, the width here is 0.5 meter. If it's x is 0.2, means roughly here, right? The normal force and friction force will be here if it's 0.2, which is still at the region, right? In this case, what is happening? It's not tipping over because it's still at the limit here, between the limit. So it will not tip over. So will it stay stationary or will it move in this case? Okay, we have to check, right? This one is 400 Newton. This one is 500 Newton. So it will what? Stay stationary. This one. Okay? So that's the way to check the condition. Check the x, check the location of the normal force and friction force. Is it outside of the area or not? If it's outside, most likely it will tip over. And you have to check as well for the static friction force. Okay? Tomorrow, before I discuss about the wedge, okay, I will discuss a little bit about the other case as well. Impending motion and moving condition. Because tomorrow, the classroom will still be here. And please come earlier than 7 in the morning, okay? Try to wake up earlier. Okay. Oh yeah, by the way, thank you very much. Okay, I think that's all for today. Okay. See you guys again tomorrow morning at 7. And tomorrow I will give a homework as well about the wage and the tipping condition. Okay. See you guys tomorrow. Bye. Yes, thank you. Thank you.
Thank you, sir.
Yeah. Yeah. No problem.